Assalamualaikum and hello to Dr. Suhaila. My name is Mohamad Wasim bin Jahabar Sadik. My group members are Kong Zhong Yang and Lee Hong Si. And today I will be explaining the arithmetic logic unit design required for project 2. So before going to quarters, I would like to first explain the specifications required for the ALU design. So as you can see here, there are two 4-bit 4-to-1 multiplexes, a 4-bit adder subtractor, and a 4-bit parallel in parallel out register or a people register. So now heading to quarters, this is the arithmetic logic unit design in quarters prime light. So there are the two 4-bit 4-to-1 multiplexer, the 4-bit adder subtractor, and the people register here. So starting with the 4-bit 4-to-1 multiplexer here, we can see that there's 2 input selectors and 16 input total with 4 output. So looking at the design file for the 4-bit 4-to-1 multiplexer, we have the selector bits here, the inputs and the outputs on the right here. Looking at the design file of the 4-to-1 multiplexer, simple. It takes 4 inputs and there are 2 selector bits which will output 1 bit at the end. So for example, if S1 was 0 and S0 was also 0, which is the least significant bit, it selects IO as the output. So that is the explanation for the 4-bit 4-to-1 multiplexer. It is the same with the other 4-bit 4-to-1 multiplexer as well. And the outputs from these multiplexes go to the 4-bit adder subtractor. So what the 4-bit adder subtractor does is the addition or subtraction of two 4-bit numbers. As you can see here, we have A and B, which will output a single 4-bit sum. So let's say, for example, if we want to do a subtraction, right? So the ALU operator here will be 0. When it travels through the NOT gate, it will become a 1, and the XOR gate input will be 1 here. So let's say for example, B0 here is 0. So the two complements of B0 will be 1, right? So let's see. So B0 goes in 0 and 1. In an XOR gate, the output will be 1. So the B0 changes from 0 to 1. So that is the two complements of that number. So let's look at the full adder circuit now. Design circuit. We have 3 inputs. We have AI, BI, and CI, Cin. So the two numbers go through, and then there will be the output of sum and the C out. So now the output from the ripple carry, which will be the sum of the operation done by these two numbers, it will now go to the people register. So what the people register does is it acts as a storage unit, and you can see here it is a positive edge rise, and there is also a bubble at the clear input. Okay, so whenever the clock shows a positive edge rise, the D flip-flop activates, and when the clear output is 0, once it gets to here, it becomes a 1. So 1 is inputted into the D flip-flop, which clears the D flip-flop and outputs 0 at the end. So there are 4 inputs and also 4 outputs. So that is the explanation for the design of the ALU. So now I will show that the design does compile. Okay, so now it's time to show the waveform of this design. Okay, now that we have the waveform, I've inputted these 3 cases in order to explain how the arithmetic logic unit works. So first we have the A selector with a value of 0, 1 and a B selector of 1, 0. So what this does is, when A selector is 0, 1, it selects A1, and when B selector is 1, 0, it selects B2. As you can see here, the ALU operation is 0. So what this means is it does a subtraction of the numbers. So what this does is the subtraction of two numbers, which in this case will be A1 and B2. So for A1 we have 1, 1, 1, 1, and B2 is 1100. So the answer we should be expecting here should be 0011. So in order to check if that's the case, let's run the simulation for this design. So as you can see here, we have gotten the answer of 0011 here, but we have gotten 0000 here. So as I mentioned earlier in the register, it has a storage unit, and only activates when there is a positive edge rise. That's why as you can see, once positive edge rises at 2 microseconds, the output is now the answer that we were expecting, which is 1111 minus 1100, which is equals to 0011. So that is the explanation for case 1. For case 2 and case 3, the explanation will be provided in the report. So that's all from me. Thank you.